outliers in a given data set. If you have, say, a bunch of numbers, 25, 29, 31, 32, and 74, what number in this list do you think is the outlier? It's pretty obvious, right? The 74 is the outlier. If this set of numbers was the time taken for a person to run 300 meters, these three people, maybe I should do it in blue, these three people are not outliers. But this one person who took 74 seconds is much slower than the rest to run 300 meters, right? So it's going to be an outlier. And if you're trying to find the average time taken, you would typically exclude the outlier from your data set. So how do we calculate this outlier? Obviously, when it's given like this, it's very straightforward. When you're not provided your data set, you might just be provided your Q1 and Q3, the lower and the upper quartile. How do you calculate it in that case? In order to calculate your outliers, there's a very simple, straightforward formula. You just need to find the lower boundary and you need to find the upper boundary. And to calculate each of these boundaries, you need to know three things. You need to know the lower quartile, the upper quartile, and you need to know the interquartile range. To find the interquartile range, you just minus Q3 minus Q1. Upper quartile minus the lower quartile gives you the interquartile range. So you need to be provided the lower and the upper quartile in order to calculate the boundaries and therefore the outliers. What's the lower and upper quartile? If you are given a data set, the middle number is Q2. That's the median. Median is going to be the 50% mark, right? So the half of it is going to be on the left side, the other half is going to be on the right side. Within each side, you can split it into quartiles, hence the name lower and upper quartile, which are worth 25% each. When you add all four up, you're going to get 100%, hence the median being 50. This is going to be the halfway point between the quartile, right? This is called the lower quartile, which is also known as Q1. This point is called the upper quartile, which is known as Q3. It's the 25% mark and the 75% mark, respectively. The Q1 and the Q3. Therefore, let's find the lower and upper boundaries. In order to find the lower boundary, the formula is very simple, and it's just, you can just understand it. There's not much memorization needed. You're going to multiply. You're going to need your lower quartile. You're going to add that. You're going to take that away from 1.5 multiplied by the interquartile range. Remember, the interquartile range is just Q3 upper quartile minus the lower quartile. I'll explain how this formula works and the reason behind it in just a moment. To calculate the upper boundary, you're going to do the upper quartile plus this time 1.5 times the interquartile range. Let's try to see the reasoning behind it. If we have our number line, this is the median Q2, this is going to be Q1, and this is going to be Q3, right? If we take Q1, the lower boundary, it starts here, and we take away something from that, 1.5 times the interquartile range. Now the interquartile range was Q3 minus Q1. It's the difference between the two. And if you're going to multiply that by 1.5, this number is obviously going to be greater than Q1, right? So it's going to be shifting to the left, and your lower boundary is going to be somewhere to the left. Anything beyond the lower boundary is going to be classified as an outlier and excluded from your data set. Likewise, to calculate the upper boundary, it's going to be beyond the Q3 upper quartile point, right? hence the reason you add this time 1.5 multiplied by the IQR, then you're going to get a number that's greater than Q3 somewhere over here, which is going to be the upper boundary. So anything beyond that number is going to be an outlier and excluded from your data set. Let's take a look at an example. We're provided that the lower boundary value, Q1, is equal to 6.5, and that Q3, the upper boundary, is equal to 10. What are the outliers? And can we draw a box plot, also known as a box and whisker diagram, which is a video I covered a couple days ago. This is a box and whisker diagram, which are also called box plots. So, and we can create a box plot to show this information. Let's find the outliers, the value needed. We have the Q1 and the Q3. So we need to know the interquartile range, right? Interquartile range is Q3 minus Q1. So 10 minus 6.5, that's going to give us 3.5. What is our lower boundary going to be? We can just simplify. Instead of writing out lower boundary every single time, we can just write LB. What's the lower boundary going to be? The lower boundary is going to be Q1. We're going to start with Q1, 6.5. We're going to take away, because it's the lower, 1.5 multiplied by our interquartile range of 3.5. What's that going to give us? That's going to give us 1.25. You can just input that into your calculator. What's our upper boundary going to be? We're going to take our upper quartile, which is Q3, 10. Because it's the upper, we're going to add this time. Same, 1.5 times our interquartile range of 3.5. And that's going to give us 15.25. Any number greater than 15.25 is going to be an outlier. Any number smaller than 1.25 is going to be an outlier too. So, if we have a diagram, let's do this first. If the data set for this information included the two smallest values in this data set, and the two largest values. This is how the question would be worded, by the way, in your IB exams. If the two smallest values in this data set were, say, so they might not always give you the whole data set, they might just give you this kind of limited information to see if you can interpret and access the information that you need. If the two smallest values in this data set were 1.1 and 1.3, and the two largest values were 16.25 and 15.15, what are the outliers in this dataset? Well, we agreed that the minimum value can be 1.25 and the maximum value can be 15.25. So anything that is less than 1.25 and anything that is greater than 1.25 is going to be an outlier. Is 1.1 less than 1.25? Yes, so it must be an outlier. Is 1.3 less than 1.25? No, it's greater, hence not an outlier. Is 16.25 larger than 15.25? Yes, hence it's an outlier. Is 15.15 greater than 15.25? No, so it's not an outlier. So the two outliers are these values. Now, given that we have found the two outliers, we have found the lower and the upper boundary, we can draw a box and whisker diagram to visualize this information. As always, we're going to begin with the number line. We now know, having done this, that the smallest value that's not an outlier is 1.3, right? The smallest value that's not an outlier is 1.3, and the largest value that's not an outlier is 15.15. Given that smallest value was 1.3, so I'll write that again here. Better to say the minimum, actually. Let's be a bit more technical. And the maximum value was 15.15. So these are values that are not outliers. Once we have this information, we can draw our box plot. 1.3 and 15, so let's make the scale go from, but we want to show our outliers on it too, so 1 to 17, I guess. Maybe 1 to 20 is fair. 1 to 20. 2, 3, 4, 5, 6, 7, 8. Oh, maybe I made the gaps too big. Just draw that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now obviously in your exams you can probably draw a much better looking number line than this, but this pretty much gets the point across, which is what matters. And obviously you would use a ruler instead of hand drawing this. So we have the numbers from 1 through to 20. Our minimum value that's not an outlier is 1.3, maximum is 15.15. So I'm going to find 1.3 and we're going to draw our first whisker there. Maximum is 15.15. Draw a whisker over there too. And we need to know our Q1 and our Q3 values, which we found were 6.5 and 10. So the edge of our box is going to be at 6.5, and that edge of Q3 box is going to be at 10. Which we can link up like so. And once we have that, we need to know our median, our Q2, which we did not find yet actually. What would our median be? We can find the median by simply finding the middle of our data set. If the Q1 is 6.5, sorry, if the minimum is 1.3 and the maximum is 15.15, we know that our median value is going to be at 8. Why is my pen not working? Median value is going to be at 8. So this is Q2, Q1, Q3, the maximum, the minimum. Now how we show outliers in a box and whisker diagram is by using asterisks. So the outlier that we found before, found two outliers, right? 1.1 and 16.25. We go to 1.1 in our box and whisker diagram. And we can just simply plot that onto the diagram. Sorry, yeah. I probably should have chosen a better number because it's really hard to show it on here. The numbers are too close. Our outlier was 16.25. This one's a bit better actually. And we just mark it with an asterisk. So these are what we call outliers. And that is pretty much all you need to know. The most important thing is you mark your outliers with these asterisks. And in order to find your outliers, you just need to know your lower and your upper boundaries, which you calculate for the lower one by taking the lower boundary, minusing that because you're trying to find the minimum point, 1.5 multiplied by your interquartile range. And for your upper boundary, you're going to take your upper quartile, adding, because it's going to be a bigger number, 1.5 multiplied by your interquartile range. Anything beyond each of these boundaries we mark with asterisks, and these are what we call anomalies. Sorry, these are what we call outliers. And you would exclude them for your data set.